Hey folks, Quill18 here, and welcome back to another Unity base building game tutorial, codenamed Project Porcupine. It's been a while since I've recorded one of these, because of course we had a big Ludum Dare and did a few other tutorials in there, but we are back and we are working on finishing this sort of like inventory system by which we could pick up stuff, use it to build things, which actually is basically done as soon as we fix a bug, as far as I know. And then after that, we're going to work on stockpiles, which is what the rest of this video is going to be. So, if we want to review here, we can load up the scene. I did change these stack sizes just to make it a little easier to test, but if we go and we build a wall over here, our character will go and grab some stuff and drop it up over here. But by making these stacks smaller, it makes it very obvious that something's going slightly off in our pickup system, which is very simple. We're respecting those limits, but we sort of hit a limit of a time limit for our tutorial last time, so we had to cut it off before we could fix it. Now, there's two places that you can fix it. On our character, while we're doing the job, we actually pick up the loot over here. We're placing inventory into a character from a certain tile, and it's asking for how much to transfer over, and right now we are saying we would like to pick up this desires inventory type returns the number of inventory items of this type, the type in the current tile, that this job wants. So right now I think our jobs, well, they require 5 pieces of metal. So this is returning 5. Now we could put in a thing around this to say, let's limit it to the number of stuff in the actual tile. But I think it's perfectly fine for this function here in our code to just say, well, let's try to pick up as much as we can, as much as we need for the job. Let's just try and pick that up. And in fact, it probably makes a lot of sense for this place inventory function here, which is potentially going to get called from a few different areas, to have the sanity check of hey, let's make sure we don't pick up too much. So we get past the amount over here, and if the amount is set to -1, then that just gets set to the actual stack size of our inventory. We're trying to pick up everything. But in our example, we're actually passing an amount of 5, so we have to make sure that we don't actually, when we transfer the stuff, say over here and here, we don't actually transfer an amount greater than exists. So what I'm going to do is I'm going to put in, so if the amount is less than 0, that's our special case for saying we want to pick up everything in that tile. But otherwise, well, I suppose I could do an else of, else if amount is greater than the amount that we actually have in there, yada, yada, yada. But it's probably easier to just say amount equals mathf dot min. And this will return the smallest of two numbers that we pass it to. So either the amount or the amount that we currently have. Amount dot stack size, right, not max stack size. So this is going to return the smallest number of either the amount we actually have in this tile or the amount we're asking for. So now amount is going to be set to a number that is guaranteed to not be bigger than the amount we currently have. So let's go ahead and play that and see what that looks like. Hit play. We're going to load this up again. We've still got our material on the ground there. And I'm going to say build a wall over here, please. He'll still go to the number 2 because of our sorting. Okay, so we're no longer overshooting it, which is good, although we are not yet cleaning up that that stack size over here, which is interesting. So clean up inventory. Supposed to go through everything. Interesting. Source inventory. Clean up inventory of the source inventory. And if that's a 0, yeah, if this is a 0, then we're removing it from the world, which is fine. But at no point are we informing our tile manager, right? Our graphic manager, which is our controller over here. So our inventory sprite controller, we are not letting it know, hey, by the way, the number has changed. Well, we're letting it know that the number has changed, but we're not actually checking for a 0 case. Right, because if the stack goes to 0, then we actually want to get rid of it at that point. So, text equals not, inventory stack size is 2 strings, so still needs to work and get called. Actually, this is working and getting called right now. So we can put in a quick little thing. If the stack size has been set to 0. Oh, well, no, I guess we still need the game object and all those things. Now, we don't necessarily need to find the text component. I guess what we'll do is we'll say this, if the stack size is greater than 0, then we're going to make changes. Then we're going to make changes to the text. Else, this stack has gone to 0, and hopefully has been purged from all the inventory stack databases, which we don't have to worry about. We're the graphical system. We actually don't care what's happening in the database backend. So remove the sprite. So what we're going to say is we're going to simply destroy the inventory game object. Okay, and that only happens at the end of the frame. So right now it's still technically there, so we can actually still reference it, which is actually quite nice. Actually, I don't know if it's going to make a difference one way or another, but it is something that you have to keep in mind sometimes. So in inventory map, we want to remove the item with this stack from that map, because we're destroying the game object, so we can remove our pointer to it. And was there anything else? Well, I was going to say, we may want to unregister the changed callback, which is this function. Now, this stack should actually be getting garbage collected anyway, so we probably don't have to worry about unregistering this, because in a moment that stack's no longer going to exist. But for the sake of, cleaning everything up, let's go ahead and do that. So now if we run this again, let's see what happens. Load, build wall over here. Boom, correctly cleans that up. Wonderful. And then the wall gets built. Excellent. Okay, I'm really happy about that. Now, there's two things we can do next. Next, it might be good to make little stockpiles. Oh, here's an interesting case. What happens if we run out of stuff? Does it correctly just like sit there? No, it starts to create. Oh, no. It's putting it back on the queue and then re-grabbing it and then putting it back on the queue and so on and so forth. Yeah, most likely job being re-queued as opposed to created. Yeah, that's all fine. So it's re-queuing the job and that's okay. We'll make that a little bit more elegant later on. Yeah, there's two things we can work on. Either we could work on the stockpile, so a stockpile, the idea is, I would like to just define a little square somewhere. And what's going to happen is it's going to create a job automatically. If this tile is empty, it's going to create a job that says, hey, grab any inventory item that's not currently in a stockpile and just drop it off in here, please and thank you. So that's number one. And two, if it does have some stuff in there, but it's not its max stack size, then it's actually going to create a slightly different job, which is going to ask for more of that particular type of thing. So that's one thing we can work on. The other thing we can work on is, wouldn't it be nice? Wouldn't it be nice? And I don't think this happens in certain games. Like, I don't think RimWorld does that. It does it for stockpiles. That was added in later patch. What am I saying? I'm saying, wouldn't it be nice if our character grabbed the 2 from here, recognized that he still didn't have enough, and then went and grabbed another 3 from another stack before going over to the walls? That would be really, really quite wonderful. And probably isn't that hard. What we'd have to do is switch this code around a little bit. So, this is our character's update do job script, which wouldn't surprise me if I broke this into a couple of different sub-functions later on, because it's quite clumsy and big. We also might replace things with a state machine as opposed to these sort of nested ifs and things like that. But for now, let's continue, and we will refactor later on. It's not going to make things easier or harder or anything like that, or more optimal at this time. But as we add more and more job functions, then it will. So the idea is, are we carrying anything that job location wants? And right now we're saying, if my inventory is not null, and the thing I'm carrying is something the inventory wants, then we go and deliver it. But what if we change that around? So what if we say, see, then we got to put in under catches, because what if we're checking to see if the amount that it wants is not just equal to 0, but is actually equal to the amount that we're carrying. Then we go and deliver the goods. Otherwise, we go into the mode where we're looking to pick up a good instead. The problem with that, I just realized, is what happens if the wall needs 5 blocks of metal, and we've picked up 2, so we're not going to go and deliver it because we don't have the right amount, but it turns out there's not another stack of metal anywhere. Then we have to worry about all these error cases and things. And you know what? At that point, with that kind of logic, I think we will wait to introduce that sort of smart pickup behavior for when we do a bit of a refactor over here and probably create some sort of state machines, because then it'll be a lot easier to say, okay, we don't have the amount that the job desires, try to pick some up. Oh, there's nothing left, then actually just move to the job delivery thing. And then that will save us from writing a bunch of complicated and annoying if statements that are sort of like nested and have a bunch of ands and ors in there. So let's instead work on the stockpile system, because I think that's something we will definitely want to have in here. So I'm trying to think, for the stockpile, I think I discussed this previously. Would it make sense to just kind of sort of have it count as being furniture? And I think the answer is yes, because any tile that's got a piece of furniture in it is probably not well suited to being somewhere where you want to store goods anyway, right? If you got a sofa there, you don't want to be storing metal plates in those tiles. So I think it's logical to assume that stockpiles and furniture are sort of like mutually exclusive things. You can't have a stockpile and an installed piece of furniture in the same tile. Therefore, we can just implement stockpiles as a type of furniture. And actually that makes a lot of sense if we decide to actually, instead of making Dwarf Fortress or RimWorld style stockpiles, what if our quote-unquote stockpiles are literally like storage shelves and things like that, things that you can see. In this case, I don't think our stockpiles, at least right now, are going to require any materials or anything like that, but you could see that sort of thing happening. You have to build chests or something like that later on. So let's go and make a new type of furniture. So I'm not going to draw a graphic for it right away. What I'm going to do is wimp out a little bit, and we're going to go here and we're going to create a new sprite, a new square sprite for us right now. It's going to be really easy to do, and we're just going to call this the stockpile graphic. That's it. And right now it's going to be a square. I'm going to give it some you cannot color this, can you? Once you apply it to something, you can colorize it, but now it's going to be a plain white square. All right, good enough. And I'll try to come up with a little graphic for it in between times. So we've got that. Then let's go and define our furniture. And if I recall correctly, it's in our world, create furniture prototype. Again, this is representing stuff that will be farmed out to an XML file later on. But yeah, let's go ahead and add a new type of furniture prototype. I'm going to copy the wall down here. And this is going to be called stockpile. And stockpile over here. It's not impassable. In fact, it's completely walkable. You can walk through this perfectly fine. It doesn't really link to neighbors. It doesn't include enclosed rooms or anything like that. And then we're going to add these prototypes in here. This is the job to build a stockpile thing, which is fine. And it doesn't really need any resources whatsoever. Which I guess means it could probably use the default job action, which I think gets created. But I think if we do this, I can't actually remember exactly how this will get used, but I'm pretty sure this is the same as the default build action, which means I could have just left this blank. But let's go ahead and keep this in here for a moment here, just to make sure in my brain that that's the way it works. And I suppose, oh, interesting. Type job does not take 3 arguments, doesn't it? New job. Oh, no. It does have a, it's actually got, I didn't realize it's got a lot of parameters. Right, title, object type. Oh, that's the job complete callback when it gets created. Which I think can be set to null by default, can't it? Job complete furniture building. Actually, we want this. Yeah, I should have just left it default. Job time. This is going to be instantaneous. Actually, that's interesting because, and this can be null for the requirements. We don't actually want our character to have to go over and create the stockpile. Or do we? I don't know, maybe we do. Because right now he would just go over it and instantly set it up. But this could be a job that is insta-completing, which might be interesting. We're sort of going back to our original setup. Remember when we were instantly building the walls without actually setting up a job? We could go back to doing that, or we could have some sort of special logic. Like, what if the stockpile build time is a negative amount of time? And very simply, any job that is meant to get queued up, but has a negative time, instead just calls its job complete instantly. And that might not be a bad little thing for us to catch. That way we don't have to do a bunch of work in the user interface to say, oh, this thing doesn't queue a job, just put the furniture down instantly. Instead, the interface doesn't really know that. It just says, oh, yeah, you want to put a piece of furniture down, and you just queue it up like any old job. But then we could define it in our data file to have this special code in here so that when we actually queue the job up, then it just instantly completes. So in our job queue, we have an in-queue function over here. We're going to put a little thing here. If j dot, what is it called? Work time? The hell did I call this? Job time. Oh, is it protected? Really? Well, we definitely don't want to be calling this directly. Yeah, that makes sense. So, but I think just being a public with a public get and a protected set. Because the only way for someone to change the job time would be to just call do work, but at least you can read from it. All right, that's probably fine. So if job time, this is quite interesting because this is not just for jobs that are going to be queued and they have a magic number. But what if for some reason the job gets canceled or requeued and someone's working on it and then cancels the job for some reason, but for some reason the job time is below 0? Well, rather than re-queuing something with a 0 job time, we should just complete it. Which means we do have to make sure that for any job where we actually want a character walking over to the site, we need a job time that is above 0. Because anything that's got a 0 job time, the character won't move over to build it. It'll just insta-complete. Presumably. You know, maybe we could also check for materials. I mean, I could just put in if it's less than 0. Or we could put in a separate flag, but I don't know. I think this is going to be fine. Job has a non-positive job time, so just insta complete it instead of in queuing. In queuing. I think that's how you spell that. Okay. J dot. So we're going to call. Oh, you can't call on complete instantly, can you? No, but we could call do work. With any amount of time. It doesn't matter. Because it's going to check to see if job time is less than or equal to 0, in which case it'll call job complete and handle all that. So we can just do a token amount of work and then return. So now that we've done that, we still have to add a button to our user interface to set the build mode, but that's fine. So we can go down here, and I'll just duplicate up the build door, and let's call this one assign stockpile. And this button, when pushed, we'll just call it stockpile. And build menu. Why don't I have you? I have the button, which is very cool, and I think I wanted to show the button. But wouldn't it be much more convenient if we went execute in edit mode and put in, I don't know, does it have to do it every frame? It's not that unoptimal. So now if we do this, execute in edit mode means that start and adjust will run in the editor. On render frame will also run in the editor. I don't know if there's any other. Maybe late update? I'm not sure. I don't think fixed update was. But the start and the update will definitely be called in the editor. So now, if I go and make an extra door, boom. Excellent. Wonderful. Assign stockpile, we also have to relabel it. Stockpile. There we go. And later on, we'll have a system for reading this from our config file. So I think if I were to hit play and load, and then did this and did that, Boom. We instantly get our little stockpile areas defined. Did that drag out the way I thought? Oh, yeah, I must have just not dragged to the tile I thought. All right, so we can quickly define stockpile areas right now. Now, they don't do anything currently, but that's okay. Now, one of the things we do with furniture as opposed to tiles is that I always had the concept that furniture is an active thing. There's a certain amount of logic in there. And in fact, we have this furniture actions file here, which again, later on will probably get replaced with some Lua logic and things. But what we could do is, let's get an update function here. Let's get a new one. So, and we're going to call this stockpile update action. So what are we looking to do? We need to ensure, yes, right, because we're not getting insurance, I think. I don't know. English is hard and stupid. We need to ensure that we have a job on the queue asking for either, if we are empty, that any loose inventory be brought to us. If we have something, then if we are still below the max stack size, that more of the same should be brought to us. Okay, so that's interesting. So, okay, getting this to run is pretty easy. If we go back to our world, which is currently simulating our XML file of configuring this stuff, I mean, we can have on our furniture over here, the one we have just created, so furniture prototypes stockpile. We want to register an update action. And it's going to be furniture actions dot stockpile update actions. And we're going to make sure that gets run every update of the game, which is basically every frame, but not necessarily. I mean, we could change it. You could easily see a situation where the game would be paused, like the game logic would be paused, but your time to delta time keeps going. Maybe certain things keep animating. Certainly you still want the user interface to be responsive and so on and so forth. So that logic is separated. So that's great. But the one gotcha here is the stockpile does need to be aware of whether it already has a job on the queue or not. And right now we don't have a way to really remember that, which is a bit annoying. Now, I'm trying to remember, do jobs get saved to our file? I don't think so. I guess we could do a quick test. We're already going to hit play, and I don't think they do. Oh, of course they don't, because we're redoing the job system later on. Okay. So, certainly on, like, loading something. So, what am I trying to say? I'm trying to say, as is, we don't necessarily need to store our job link as any sort of parameter. But what we might want to do on our furniture, oops, not the sprite controller, but over here, and you can definitely imagine a situation where furniture could have a lot of jobs on its queue, or not necessarily a lot of jobs on its queue. A lot of different types of furniture may have the desire to put something on the job queue. It could be a workbench that is looking for someone to come and do some work, right? It could be something that's broken down, in which case it's making sure that it's got a repair me job on the queue, and so on and so forth. And so we could easily imagine that it's probably not wasted, I think, if we had just a sort of like list job, like jobs related to this furniture, jobs created by this furniture, really. This doesn't include construction jobs. This is jobs that an installed piece of furniture is generating on its own and wants to track. So we have the need to initialize our jobs list. equals new. There we go. Expected some autocomplete. And we don't want to copy any existing jobs list. We just want to instantiate a new one, because obviously we're going to need to generate our own jobs rather than just copy an existing one, because things wouldn't point properly, right? You can't, jobs point to a specific piece of furniture, to a specific tile, etc., etc. So we've got this. And what's interesting is the jobs the piece of furniture generate don't even have to be pointing to the tile the furniture is in. In fact, I'd say most jobs are probably going to point to an adjacent tile or something of that nature. And or we're going to be putting in some logic later on for a job to say whether you have to be actually standing in the tile to do the job, or if adjacent is okay. Actually, we might want to go and throw that in right now while I'm thinking about it, because a lot of people have been wondering about when we construct the walls. Right now we make it so that the person actually stands on the wall, right? So let's hit that. And some people don't enjoy that. Let's load, right? If we say build a wall over here, our character will actually go and stand on the wall. And a lot of people want the character to stand adjacent. And I certainly agree. I think that's the way to go going forward. I wasn't too stressed about it because it's a really easy change to make. I didn't want to just do it. See, what we could have done, what a lot of people have done on their own copy of this, is when we walk towards the job, okay, as we do movement, what they say is, oh, if you stop moving one tile before you run out of the pathfinding, or you pathfind, have the path return one less tile, then you will end up in an adjacent tile, and that is true, but there's plenty of cases where to do a job or something like that, you may actually want to stand in the destination tile. So I think it's going to be better is if in our job description, we have a little flag of like stand in tile, or I don't know if it's better to have the Boolean be called like stand in the tile, or if the Boolean should be called stand adjacent. I think maybe stand adjacent might be the better way, because stand in tile feels a little bit awkward, whereas stand adjacent, you know what it means. And if it's set to false, it's like, okay, don't be adjacent, be actually in it. So we could set something up in here, and then use the character stuff to read that. But again, I think because we're going to be redoing some of the logic in here and cleaning it up and going to state machines, I think I'm just going to wait. So right now, we're still going to stand in the tile, and that's fine. Anyway, right, so our furniture now has an array, or a list, I should say, in our furniture, a list of jobs that it can reference. And I'm wondering if this should be accessible in any way. Because there's, to a certain point, like furniture actions over here should almost be able to like poke in there. But I think a few helper functions as a way to access this is going to be fine, especially since we might change your internal representation. So let's just go and sort of write some code that would describe the way we would like this to work. So what I would like to do is something like, well, first of all, if, yeah, how do we know if we're empty or not? I guess it's our current tile. Yeah, sure. Well, all right. So furniture, we've got a tile, and it's got inventory. So if the tile inventory is equal to null, then we are empty. Just ask for anything to be brought here. So what we're going to do is we're going to create a job J, which is a new job, and it obviously needs some stuff. The tile is going to be fern.tile. The job object type is really nothing. This, I think, is for visual purposes. Ah, that's interesting. So I don't know if you can specify null for a string parameter. I don't know if this is null or if it has to be an empty string. We're going to take a look at that. But also, before we get any further, in our, oh, we can stop running here. In our job sprite controller, that's what that string is for. It's basically to, right now we're using it as a hint for the job sprite controller to, as terms of what sprite to render. So job object type right over here. So what we'll do is say, if job object type is equal to null, this job doesn't really have an associated sprite with it, so no need to render. So we just bail early and say, all right, that's fine. Again, I think you might be able to null. We'll see. We'll just keep typing away and then go where we can from after that. So if I do this, oops, do that, and come down here. Okay, on job complete. Oh yeah, see, this is going to be an example of something that's got no job time. It takes 0% effort to actually do this. But it's obviously not the job that should auto-complete, right? So we really want to be able to specify a job time of 0 over here. Okay, so I think that tells me something about job queue. So just if it's less than 0. So job has a negative job time. So it's not actually supposed to be queued up. Just insta complete it. There we go. All right, I think I like that logic a lot better. So with the 0, we actually want, I mean, we could have put in, you know, a microscopic amount of time or something like that, but I think that feels kind of weird. Already have one magic number with the negative. We don't really want, like, more sort of funny stuff over there. Okay, so, oops, I'm skipping ahead. Yeah, what's the job complete? Is it null? I guess, yeah. I mean, when someone drops some goods in the stockpile, we really don't have to call anything here. This job will kill itself, and this is running on every single update. It's reevaluating if the job needs to be created or not, or whatever, you know, something of that nature. So I guess that's probably fine. Inventory requirements is quite funny, because we kind of want to define all the things. And I kind of feel like we can do that. So right, because I kind of want to say, like, my inventory requirements, this is, it wants an array, right? And I could do it as a real shortcut. You know, inventory array of size 1. Like, because right now I know there's only one type of inventory, right? And then it is a new inventory, and of type, well, I know metal plates is the only type of inventory we have now. Max stack size, I think, is 50, and right now we have 0. So if I pass this, it'll define the requirements. And I could, in here, pass an array that is basically a list of every single item type in the game. And we could have that as a sort of constant that all of our stockpile jobs use. And we just make sure that the numbers always stay to 0 for this one, because it's just like empty stockpiles all share this particular requirement. It might work. Alternatively, you know, can I flag something else here? Like inventory requirements. Can I make like a dummy one that doesn't actually match a type? Like, you know, some sort of like star all. The stack sizes don't really fit. They don't really make sense though, because some things are not stackable. Huh. Is interesting to consider. For now, what I'm just going to do is define metal plates over here. We're just hard coding some stuff in, getting our world logic to work. Speaking of world, I'm just making sure that that's actually what I called that stuff. I'm pretty sure it is. Well, I guess I could have checked it in the inventory requirements. New inventory. Oh, it's just using the default name. We're not even naming things. It's just using... Hang on. How are we actually... Am I seriously not assigning this to any sort of default name? What? I guess I'm not. I'm just assuming they're metal plates. But, oh no, there it is, steel plate. Okay, I was gonna say, but if we don't assign it, no, there we are. I don't think I had the constructor in place when I initially wrote this stuff, which is why I'm manually setting the numbers. So really, I should probably be using this version of the constructor just so that, you know, things made sense. This die is 50 and a stack size of 2. And then same thing over here. And then get rid of the existing stack size. And then again over here, get rid of that stack size. 4 and 3. Okay, there we go. So steel plate singular is what we're using. Instead of metal plates, steel plate. There we go. Make sure that matches. Obviously, this is all placeholder stuff, just to see if our job logic is working, our character logic. So, fix me. Need to be able to indicate all/any type is okay. But for now, we'll just list the one, and that's going to be okay. We don't need that closing parentheses over there. So what we're going to do is we're going to make sure that our jobs actually, fern.jobs. Oh yeah, helper function. Right, okay. So clear jobs on furniture. This is not a function yet. And then fern.addJob, which is this. Now, we're always recreating this job over and over. That doesn't make any sense, does it? Not really. We want to say, like, do we already have a job with this? And then how do we know that the job's been completed? So when a job gets picked up and someone's working on it, it's no longer in a queue. Well, how do we know it's completed? Well, of course, we have a callback for that. Now, right now, we're setting that to null, but I guess we don't have to do that. Right? Well, this is the string that we want null. But this right here is our action. So if we do action, whoops, job, stockpile, job complete. Oh, right, we don't define it that way. We say void job J. That's all that returns, right? Job complete just returns that, but how do we know what piece of furniture this is related to? Because job doesn't have furniture, but it does have a tile, which then has furniture. So I guess that'll work. So I guess what we can do is say, if we have any jobs, then we don't have to run this. Like, do we already have a job? If fern.job count is greater than 0, then we can just return. Otherwise, we try to do this. All right, so when a job is complete, we say something like this. We'll need a slightly different case for when we already have some type of inventory sitting here and we're just asking for more, but let's get that going on here. So it looks like we need sort of 3 functions in furniture to be able to interact with the job thing. We could, of course, just make this jobs list public, but let's go ahead and do it via little helper function. So public, let's say int, so we need a job count. So we're just going to return jobs.count. Why are you yelling at me? Oh, because you're not a function. That's right, you're a property. Then we're going to have a public void add job j. So obviously this is going to be just jobs.addj. We could check to see if it's already in here, something like that, if that's the sort of thing that could happen. It might be, I don't know. And then, what's the last one? Clear jobs. Public void clear jobs. So for each job j in jobs, we're going to say job q dot, how do we get the regular one? I guess it's just from the world. So tile.world dot job q dot, we need a remove here. Remove j, which I believe you can do with the job queue, like with the, rather I should say with the queue. Public void remove job j. So the actual job queue dot remove. No. Oh. And I can't just dequeue it. I mean, a queue is supposed to be processed in order. Yeah, so I think what we may actually have to do, I'll have to double check the documentation on this, but I think what we actually have to do is a little bit of an unoptimal sort of magic thing here, which is really not good. But let's just do it for now, and then I'll check the documentation later. Jobs equals new list of jobs, and we're going to pass it the job queue. So we're going to turn this job queue into a list. Then we're going to take the list and remove j, which is probably the sort of thing this would have to do internally anyway, because I suspect this is just stored as a bit of a linked list or something like that, as opposed to a searchable array, which makes a lot of sense for an actual queue. And then our job queue, we can instantiate a new one based on, I believe, yeah, we can send it a collection of this. So this should restore the job queue to the same order it was in before, but with the item removed. To do. Check docs to see if there's a less memory swappy solution. But this should work. It may not work, as well as we'd like, but it should at least technically function. Cannot declare instance members. Oh, yes, right. Has to be static. Okay. Let's take this out for a wee spin here and see what happens. So if I asked you to do a stockpile right there, well, the stockpile gets built. Oops, I saved. Is that something I'm happy about? I guess that's fine. If we load, the stockpile's there. But I don't think it's putting its job on the queue. I'm thinking that this is not running. Let's just check. Debug.log. Let's just verify if this is running or not. I don't think we actually assigned it to the furniture definition. Oh, no, it is running. Okay, because as you can see it in debug log. I should probably just run this in debug mode to see exactly what's going on here. Oh, we add the job, but we don't actually queue it. So I create the job thing, I add it to my own personal list, but I'm not actually in queuing it, which, to me, I think that's what the job stuff should actually do. So if we go to tile.world.jobqueue.inqueue, j at this point. Actually, job complete, we don't necessarily need to... Well, I guess we know this particular furniture only, or this stockpile, well, this furniture, I guess, only ever has one job in the thing. So clear jobs is fine, but really, we only need to remove that one from our array. So I could put in, we don't need to use clear jobs. Public void remove job job J, which is going to be, oh, we could also do a little check too. Jobs.remove J, and then this over here too. And in our job queue, I believe this will give us an error if we're trying to remove something that's not in there. Which is interesting, actually. We should put in just a debug log error for this. If jobs.contains J equals false, debug.log error, trying to remove a job that doesn't exist on the queue. Like, why would that happen? I don't know. So let's just put in a little note so we know it's happening rather than just returning instantly. We should know if something like this happens, because I think that would be weird. Maybe we'll turn into a situation where that's completely fine and intended, but not for now. So yeah, remove job. So our furniture action over here can actually be remove job J instead. Okay. Does not contain what? Did I not save that file? Ah, I didn't save it. Okay. Let's say, yes, it contains a definition. For that, I just wrote it. Load. So that is now running, and clearly the job's going on because he's starting to work. But it keeps returning that the tile has no inventory. Why? Oh, because this is just asking for more and more and more of this. Okay, when our character delivers the item to the job, it adds it to the job, not to the tile itself. So what we have to do is say something like j.tile. No, I guess it's what do we do? It's j.tile.world.inventory-manager. Place inventory in a tile. So our job's tile, we are going to place in the inventory from the j.inventory requirements. Again, here we know well, that's not true, actually, that we only have the one. For now, this is not good to do. Change this when we figure out what we're doing for the any pickup job. But I'm going to do something like for each inventory, inventory in inventory requirements, which is just an array or a list of these inventories. Well, no, because it's not for each. I guess it's the first one. If inventory dot stack size is greater than 0, then that's the one we add in over here. And then we return. There should be no way that we ever end up with more than one inventory requirement with stack size greater than 0. Because as soon as it's not job complete, actually. Hold on. Ooh, right. Ooh, the job's not actually completing here. Right. That's interesting. The job would only complete when this would get completely full. But that's not necessarily accurate. Because here, again, there's sort of two modes, right? Because in the situation where, let's say our stack's not empty, right? So else if else is if the inventory is not empty. Like, else is if this stockpile tile has any kind of inventory in it. So I guess else if fern.tile.inventory.stack size is less than fern.tile.inventory.max stack size. So in this case, we have a stack of something started, but we're not full yet. So in this example, what we do is return the difference. Now, we don't need to make a new one. Because actually, as interesting as it is, really, we can just basically give it our own inventory. Because this inventory will have a stack size and a max stack size, which is correct. So then all of a sudden, when we're dropping stuff in, it's going to be correctly dropping stuff into our existing inventory. I don't think that's what we want to do. I think we do want to make a new dummy one, because we're going to be placing it into our tile later on. This is the desired inventory is equal to a new inventory, which does have a, has that. Do we have a, I think we've got a clone tool, don't we? For this, yep. So we clone our existing inventory, but we're going to do a quick little fix where our desired inventory dot max stack size is going to be reduced by its current amount, and the current amount is going to be set to 0. But again, we don't want to be notified when the job is complete, although I suppose that's fine. We actually, well, again, for this version, it's fine. Just go until the job is complete, and then we make sure to clean up everything. No, we do need to be told every time the job gets progressed rather than completes, because every time it makes a little bit of progress, basically as soon as any goods get dropped onto this job, we want to instantly add it to our actual stack, not be in this, because anything that's in that's been brought over for a job is in this sort of ephemeral sort of situation where it's not part of the regular inventory system. Because obviously no one can just go and pick up stuff. If I'm putting some steel plates in a tile to be built as a wall, I don't want someone to go and pick up these steel plates to be used for another wall somewhere else. And right now that wouldn't be the case, because when we drop off steel plates in a square to build a wall, they're not actually part of that tile at all. They're just part of the job. They don't exist in the world in any way whatsoever. But obviously when we bring any sort of stack to a stockpile tile, as soon as it gets dropped there, we don't want it to be existing just as part of this job. We want it to actually be dropped on the ground as part of this tile. The other thing we're going to have to do is add a little bit more logic in here to not pick up stuff from other stockpiles, which is interesting. So we might need slightly more logic for the job. Like, imagine, for our job, we could have something like, we could have another callback for on-job progress, which actually is a pretty good idea. Because right now, we don't track that. But it's very easy to imagine that we might want our sprite graphic to change as our job is getting built, right? So it's, you know, it's filling up, or it's got a bar, some sort of percentage that's being displayed. So we probably want a callback that gets called every time there's work done. So we're going to want action job callback job worked. So whenever a job gets worked, and we can call that over in do work over here. So as if work time, no, anytime this gets called. I was gonna say if work time is greater than 0. No. So just if this is not equal to null, then we call. We say, hey, you've done some work on the job, and then after, if the job is complete, we do this. So that's fine. And then we can change this up to require that callback to get passed here. We probably want to add it after this one here, just to keep them stacked up well. Do we want to reorder some of these things? I don't know. I think it's fine if I just do this. Oh, we actually, that's interesting. We're requiring the job complete. I guess we don't have to require the job worked callback. We can instead just add a way for people to register that, because a lot of people don't necessarily need that. So, and Dun, dun, dun. CB job worked and worked and worked and worked. Yeah, and that's how we're gonna do it. Okay, so all this stuff with the completed like wasn't feeling quite right. We don't care when either one of these jobs get completed. That's irrelevant because we'll have already taken care of what we care about from our job worked function over here. And what we're going to do here, so we need to make sure that j.register job worked callback is going to be this over here. Excellent. Whoops. Well, I guess that was technically syntactically correct, but it looked stupid. So we're going to do that and do that over here. Okay, so every time the job gets worked, this will get called. And what we're actually going to do is we are then going to remove the jobs, purge them all, and then redo them over here, which... that's interesting. Does our character get informed if a job gets canceled? Yes, it does. Oh, yeah, remove job over here. Right. This doesn't necessarily always generate an error. Or, well, I mean, it sort of will here, but it's actually okay because it is legitimate that this job, when we remove a job here from our furniture, it may not be on the queue because instead a character might have it. Does cancel job remove us from the queue at any point? No, it doesn't. Oh, yeah, because we don't actually do anything that would cancel a job right now. But obviously, we would probably want something like that. So if a job gets canceled, hey, we'd probably like to do something like tell the world. And the only way we have access to the world here, I can't do world.instance, although I probably should. Because I was going to say, what we've been doing is something like tile.world.jobqueue. And then we'd say remove this in case we were still in the queue. If a job gets canceled, it may have been canceled and not actually claimed by anyone yet. It might still be on the queue. So we call any job cancel callbacks there are and make sure to remove us there. But tile will actually be null for certain things. Or will it? I don't know, it might be. I guess for now it's fine. When we run into an error, then we'll go and change things up at that point. For now, I guess we can assume that these tiles will exist. Okay, so we make sure to dequeue us over there and cancel the job if required. Same thing over here. And then jobs equals new list, which I'd forgotten to do before. There we go. Cancel the job, remove it, and then remove it from our array by basically making a fresh array over here. Alternatively, I could have just called remove job in each one of these, but this will be technically slightly faster. I don't know. You know what? This, again, will be slightly slower because we don't get to optimize our little list thing, but it guarantees there's only one place where I'm having to call this stuff correctly. So there we go. So clear jobs just calls remove job on everything. And furniture action will be called every time the job gets worked, which is to say some stuff gets delivered. Actually, I don't think that's true. When our character drops some goods, right here, this is where we deliver goods. That doesn't actually work the job. That's not it. Sorry, my bad. We're carrying anything that the job wants. Yes, we are. If we're there, place inventory. So right over here, we're at the world to drop inventory. We could come up with another callback, but I think it's probably fine at this point if we just do something like do work 0. This will call all like CB job worked callbacks because even though we aren't progressing, it might want to do something with the fact that the requirements are being met. Right? Again, it might decide to show something visually, or in our case, with the furniture, we're going to want to regenerate these jobs sort of over and over. There we go. Okay. This code is not done yet. It's not going to work. And again, tons and tons of placeholders in here at this time. But, well, mostly this part. I think this part is starting to look relatively good. Is this part vaguely working the way I want? Yeah, because basically by doing this, we're canceling all the jobs and everything like that and purging it out there. Which will then get recreated over here. Well, no, this code is not right yet. But I got to put a cut in here. It's been an hour, unfortunately, so we've got a little bit more work to do. Again, here I was sort of just spitballing some code down to try to get an idea of what kind of requirements we need for furniture and all those things. I think we've now met all those requirements, so I think what I'm going to do now is actually, in the next one, we're just going to just rewrite this to be in a slightly more logical way. But again, this is something I'm going to have to consider. What are we going to do to indicate that we want all the things in here? And it might just be a sort of a magic number where like some sort of value in here or another flag or something that gets set. So when our character is looking to see if they can drop something off, like my job needs to just set return true for like desires inventory type. I guess that's it. For desires inventory type, we've got to have some value where it just says yes for everything. And I think that just might be a special case because literally the only thing that'll ever care about that is the stockpile. So I think sort of inventing a larger system might be a little too contrived, and having a big array would sort of suck. But we could just have like just honestly a public boolean here that says accepts any inventory item, and it defaults to false. And then you just, there you go. You have a check for desires inventory type. Something like if desires accepts any inventory item, then it returns that yes, it would like one, and specifically, it's limited to max stack size of whatever that item is. So that way, if you're asking about a piece of furniture that's just being stored or something like that, like an uninstalled piece of furniture that is in its box variety, but can only stack to a maximum of 1, then we're going to do that. So if there's a packed up sofa on the ground somewhere, and the character says, hey, is this something that you desire? And then the game says, yeah, sure, I'm happy to have that. Done. So that, that's an interesting little potential thing in there. But obviously we're going to have to check a little bit more thoroughly. So stockpiles are going to be a little bit interesting to manage. And then again, we'll rewrite the character stuff to enable our character to pick up multiple items in one go right now. Oh. What's this one for? Oh, right. Inventory requirements is not just... I guess it could loop through all the values. Sure. Yeah, that's fine. Dot values. That should be okay, yeah? And then something doesn't take 0 argument. Oh, we have to pass it the job itself. Oops. In there. Just want to get it so it technically compiles right. But again, I'm pretty sure we get some pretty disastrous stuff right now. If I hit load, we've got our stockpile. But yeah, I was going to say, we're going to get errors and things are going to go badly. And I'm going to leave it there. This video's gone on long enough. Thanks for watching, folks, and I'll see you next time. Thank you to everyone who pledged to support this project in March and is therefore funding these videos from April to early May. And especially these Mike Check supporters. A lot of familiar names. Wes Oldenboving, Craig Mortel, Neil Blakey, Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toibson, Marius Fieldvold, Jan Torivel, maybe, I hope, Julien Auger-Lafont, Stephen Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and absolutely everyone who just watches and favorites and likes and comments and has subscribed to the channel. You guys make this continue to happen, and I appreciate it so much. See you next time, folks.